Magnetic field. Magnetic field is the space or the region around a magnet or a moving charge carrier or a current carrying conductor where its effect is felt. This is called magnetic field. Magnetic induction field at a point can be located or can be seen by drawing magnetic field lines. These are the imaginary lines traced by a unit north pole moving in the field of a bar magnet. The magnetic induction field of a point at a magnetic field is the force experienced by unit north pole of 1 ampere meter kept at that point. It's a vector quantity. The direction of the field is drawn, or we get it by drawing a tangent to the magnetic field lines. The closeness of these lines gives the magnitude of the magnetic field. So what is the magnetic field? Magnetic field is the space around or the region around a bar magnet where its influence can be felt. The space or region around a magnet where its effect is felt is called magnetic field. To find the magnetic field, we take the help of a unit north pole or compass. The movement of a unit north pole near the magnet can give us the distribution of the field. So we will trace the lines like this. Unit north will place, it will move away from north and go towards south. As they move, we trace a line. These are called magnetic field lines. These magnetic field lines will tell us about the distribution of the magnetic field. The magnetic field of induction B at a point in a magnetic field is the force experienced by a unit north pole of 1 ampere meter kept at the point. It is a vector quantity. The direction of the force experienced by unit north pole. If m0 is the unit north pole placed in the magnetic field B, the force experienced by it at that particular point when it is placed gives the B value. If m0 is a test pole placed at a point in a magnetic field, then the force experienced per unit north pole gives the magnetic induction or magnetic field induction. SI unit is 1 Tesla, that is equal to 1 Newton by ampere meter. Dimensional formula will be m t to the power minus 2 a to the power minus 1. Magnetic field induction is same at all the points of magnetic field if the field is uniform. To locate the field, we have to draw the lines we call magnetic field lines. Magnetic field lines are lines of forces. It represents a set of non-intersecting curves that represents the direction in which a unit north pole experiences a force if it placed at that point in the magnetic field. The direction of the magnetic field induction at any point in the magnetic field is along the tangent drawn at any point. Tangent drawn to the line of forces passing through the given point. Magnetic lines of forces for a north pole diverge away for a south pole, converges into the south pole. The magnetic field induction at a point due to north pole producing the field is directed away from north pole towards the south pole. Magnetic field lines are the closed curves. These lines of forces are closed curves. They repel laterally and contract longitudinally. The point in the magnetic field where the magnetic field is zero is called null point. These are the lines traced. The magnetic field lines are the lines traced by a unit north pole moving in a magnetic field. The closeness of the lines gives the magnitude of the magnetic field. The tangent drawn at a point to the magnetic field line gives the direction of the field. These lines never intersect because at the point of intersection there will be two directions to the field. They are always from the north pole to the south pole outside the magnet. They are always in the form of closed curves. So between north and south pole of a bar magnet, they start from north heading towards the south like this. If north and south it's taken like this for one bar magnet to another, they are from north pole to south pole. North, north, same. So there will be repulsion. So magnetic field lines will be traced like this. There will be a point between these two where the magnetic field becomes zero. This is called the null point. The point in the magnetic field where the magnetic field is zero, the point in a magnetic field where the resultant field is zero is called a null point.